Okay, good morning everyone. Okay, here's the second video on the speed of reactions. So we're going to continue with page 10 of the speed of reaction notes. Okay, so for this part, okay, we are going to look at factors that affects the speed of reaction. Okay, so first thing first, for a reaction to occur, reactant particles must collide with one another, and then when they collide, the energy must be greater or equals to activation energy for the reaction to happen. So what's the activation energy? Is a minimum amount of energy that the reactant particles must possess in order for reaction to happen. Okay, of course I won't test you what's the definition of activation energy. It's more of like just to understand, okay, what's this term called. Okay, so yeah, okay, so for a reaction to happen, the reactant particles must collide and then collide with energy greater or equals to activation energy, okay, which is the minimum amount of energy that the reactant particles must possess for reaction to happen. Okay, so these collisions are what we known as effective collisions. Okay, usually an increase in effective collision will increase the speed of reaction. Okay, so we are going to look at four factors that affect the speed of reaction. Okay, one is concentration, okay, which apply for solutions only. Okay, pressure for gas only, particle size for solid, and then temperature. Okay, temperature affects everything lah. Okay, solid, liquid, gas. All right. Okay, and then particularly concentration is a tricky one. Okay, depending on whether the reactant is the limiting or is it the excess reagent. If it's excess reagent, usually only affects the speed of reaction. Okay, or otherwise rate of reaction. Rate of reaction is speed of reaction. Okay, if it's limiting, okay, it's going to affect two things. Okay, not only the speed of reaction, okay, but at the same time it's also going to affect the volume, okay, of gas, right? Okay, or otherwise the amount of reactant that you are amount of products that you are going to get. Okay, okay, right. Okay, so we're going to go into this thing, okay, called the collision theory lah. Okay, so a lot of times questions will ask you to explain speed of reaction in terms of reactant particles, reacting particles, or sometimes even this thing called the collision theory. Okay, they all mean the same thing. That means you must explain in this sort of format. Okay, we're going to take a look at the four factors. Okay, firstly is temperature. Okay, at higher temperature, basically they will gain kinetic energy. Okay, and then the reactant particles will collide into each other more frequently and with more energy. Okay, and then more particles collide with energy greater or equals to activation energy, and then this leads to an increase in the frequency of effective collision. All right. Okay, you notice all these 4 points. Okay, at higher concentration there will be a increase in the frequency of effective collisions. Okay, but just the first two bullets is different. The last bullet is pretty much the same. Okay, so at higher concentration, the number of reactant particles per unit volume increases. So the reactant particles collide into each other more frequently, right? And this leads to an increase in frequency of effective collision. Okay, as for surface area, generally if it's more finely divided, later on I'll explain a bit more. Okay, why is this so? There will be an increase in the total surface area. Okay, and then there will be more surfaces exposed, okay, for the reactant particles to collide into. Then they collide into each other more frequently, and once again increase in the frequency of effective collisions. All right, okay, so this part is on the collision theory. Okay, Okay, so the next few pages we are going to explore what the effect of the different factors on speed of reaction. Alright,